All right, so here we have y equals log base 2 of 4x plus 16 minus 2. We're going to graph this. We're going to state the domain and range. We're going to state the asymptote, and we're also going to talk about what transformations are happening. So to start this, it's actually very similar to how we started exponential functions when we're graphing them, right? We always want to look at just the parent function, okay? So remember, the parent function is your function with just the base. So the parent function of this guy, we're going to ignore all of the transformations for a moment. The parent function is just going to be y equals log base 2 of x. Everything else there is a transformation. The rest, transformations, right? 4, transformation. 16, negative 2, all a transformation. The 2, however, is not. It is the base of your function, okay? So if we talk about what these transformations are, remember that inside the function, that's going to be a horizontal transformation, okay? That's going to be things that are happening horizontally. Remember, with horizontal, we do everything opposite. And then things outside the function, and there's nothing here, but, you know, say there was a 2 here, that would be vertical. So this is vertical. Okay, so let's start by seeing what they mean, right? Remember, with horizontal, we do everything opposite. So that 4x, we're going to be dividing by 4, which is going to give us a horizontal compression by 4. It's going to be a horizontal compression by 4. That plus 16, the plus 16 is going to be a horizontal shift to the left. Okay, we're going to the left because it's plus. But here's what we need to keep in mind. When we do this to our table of values, we first subtract 16, right? Algebraically, we first subtract 16. Then we divide by 4, right? So this is actually going to be a horizontal shift left 4 units, okay? Because we're going to go 16 to the left, right? First we would go 16 to the left, but then we compress everything by 4. So it's actually by a factor of 4, so it's actually only moving 4 to the left, okay? With vertical shifts, we do as it says, right? So we're subtracting 2. That's just going to be a vertical shift down 2. Okay? So that's what these look like. And this is also growth because 2 is greater than 1. So we know that the function is going to look something like this when we connect it, right? But it's going to be, you know, a little compressed horizontally. So maybe it'll look like that and shifted around. Okay, so this is important to know so that we can have an idea of if our points make sense. Okay, so on the next slide, let's find the points. All right, so looking at this, we knew that our parent function was y equals, you know, log base 2 of x. But that's a problem because we can input things to that technically, but our calculators can't do this. And also our mind can't do this, right? You don't know what that is yet. You're not familiar enough with logs, you know. But what we are familiar with is exponential. So we need to use the property of logs that says, you know, y equals log base b of x is the same as b to the y equals x, to rewrite this as an exponential function. Because once it's an exponential function, we can actually input values and evaluate it. So the base stays the same, but the inputs and the outputs switch. So our input was x, now it's going to be y. Our output was y, now it's x. Okay, and this is something familiar, right? Now we can move forward as if we're graphing an exponential function, right? We've got 2 to the y equals x. We can make an xy table, but we just have to think like we did with exponentials, right? So the difference is I'm not going to plug in for x this time. I'm not going to plug 0 1 and negative 1 in for x, because that doesn't, what does that do for me? This does nothing. I don't know what that is. But if I instead make my input the y, and I plug 0, negative 1, and 1 in here, well, 2 to the negative 1, right? I replace y with negative 1 is 1/2. 2 to the 0 is 1. And 2 to the first is 2. Okay? That's going to allow me to find points and have starting points. Okay, and if you wanted to, you could plug in negative 2 and 2 as well, right? There's nothing to stop you. You know, honestly, let's plug in 2 to give ourselves a little more to work with, okay? You can do as many points as you want. It's just vital that you do at least 3. And again, we choose these points, 0, negative 1, and 1, because they are the base points for the parent function. And, you know, if I just willy-nilly plugged random things into this function here for x, who knows if I'm going to get a reasonable answer, right? So we're trying to shift, instead of just plugging in and graphing random points, what we're trying to do here is shift the function around its transformations. So if we think back to the last slide, right, when we were talking about transformations, we had 2 things happening horizontally. So we need to pick the order. We need to determine which one we do first, right? It does matter. And remember, with horizontal things inside of a function, we always do everything opposite. That means opposite order of operations and opposite operation. So the first thing we're actually going to take care of here is the 16. Right? Because usually in PEMDAS, addition comes after multiplication. But because we're doing reverse PEMDAS, we're going to take care of the 16 first. But remember, not only do we do reverse order of operations, we do reverse operation. So I'm going to subtract 16 from all my x's. Okay, and that's going to give me 1/2 minus 16 is negative 15.5. 1 minus 16 is negative 15, 2 minus 16 is negative 14, and 4 minus 16 is negative 12. Okay, the next thing I'm going to do to my my x values is take care of the 4. Now, the 4 is being multiplied. We undo multiplication with division. Okay, so I'm going to divide all my x's by 4. So we will have negative 3.875 is negative 15.5 divided by 4. Negative 15 divided by 4 is negative 3.75. Negative 14 divided by 4 is negative 3.5. Right? You can see that these are a lot closer together, right? Because we're horizontally compressing it by 4, right? That's what we said would happen. You can see that the distance between these numbers is bigger than the distance between these numbers. They're horizontally getting closer together. And this would be negative 3. Right? For my y coordinates, I only have one thing happening outside the function, right? We go back here, we had one vertical transformation. It was being vertically shifted down 2. Okay, so I don't have to worry about order of operations. If there was something here, I would do this multiplication first and then this subtraction, but there's not, so we don't have to worry about it. So we can just right off the bat subtract 2 from our y's, right? Because remember, for our y coordinates, we do what it says. It says subtract 2. Well, I'm going to subtract 2. Negative 1 minus 2 is negative 3. 0 minus 2 is negative 2. 1 minus 2 is negative 1. And 2 minus 2 is 0. Okay? Only had one transformation of y's, so they're going to stay the same here. We got negative 3, negative 2, negative 1, and 0. Okay, so now that we have our transformed points, we're just going to take a look at this last table and plot those points, okay? And just doing the best we can. So really, really close to negative 4 on the x's, negative 3, negative 3.75, negative 2, so just a little farther over. Negative 3.5, negative 1, so right there in the middle. And negative 3, 0. Okay, so that's very, very temptingly like, yo, that's a straight line, right? I can connect those with a line. But remember, we're graphing a logarithmic function. So we got to go back to what we know about the fact that this is a growth function. And then our curve's going to look something like this, right? Because it's been shifted around and horizontally compressed, it's a little more like that. But knowing this and understanding this allows us to take these 4 points that seemingly don't mean a lot and connect them in a meaningful way, okay? In addition to knowing the general shape, we always want to put the vertical asymptote, or horizontal if it was exponential, in place to give us a guideline of what our curve is going to look like. Okay, so remember, with a normal function, if it was just like log base b of 2, base of x equals y, its vertical asymptote would be x equals 0. Okay, but look at these transformations we applied to all of the x's. The same thing's going to happen here, right? First, we shifted everything. 16, so that would give us x equals negative 16. But then we horizontally compressed, so we divided all of our x's by 4, so that would give us negative 4. Okay, so the vertical asymptote here is going to be x equals negative 4. Okay, you can kind of see from how the points are lining up, right? It's like really slowing down. It's really getting close to negative 4 here. That's our asymptote, but you can also take it from the transformations of functions. Okay, so now that I have all that information, I know, my curve's going to follow like this. Maybe that was bad, right? It's going to follow like that. It's going to get really, really, really close to the asymptote. Really, really close to x equals negative 4. Almost discernible to the eye. And then it'll just curve up like that forever. Okay? So you want to make sure, you don't curve it down. It's not going back down. Okay? It's a slow build. Slowly going up forever. Okay? So we've got that our asymptote was x equals negative 4. Okay, our range, it's going down forever. Right, the function is clearly going down forever. And it's slowly going up forever. So our range is going to be negative infinity to infinity. And then our domain, well, notice, the function is going to the left forever. It's for sure going to positive infinity. But you can see that the function, it basically starts at negative 4, right? We already plotted a point negative 3.875. It's going to keep getting closer and closer and closer to negative 4, right? It's going to get closer and closer to that asymptote. But because it's an asymptote, it's never actually going to touch there. Okay, so we're going to say that our domain starts at negative 4, but we're going to put a parenthesis there to say it's never actually going to touch negative 4. It's just going to get right up to it. Okay? All right, I hope this helps clear some things up. Again, remember, if there was say that there was a 2 here, we would have first multiplied by 2 and then subtracted 2. Okay, that would have been a vertical stretch. So, or if there was a negative, negative 2, whatever. But other than that, this pretty much, I think, covered it all. So let me know if you have any questions on your homework tonight. But I hope that this is something helpful.